Hello, good afternoon dear students. Hope you all have viewed my previous video. In that video we discussed about how to score maximum marks in your board examination. Some of the tips we discussed. Right. Today in this particular video, let us discuss about one of the most important problems in the chapter triangles, that is basic proportionality theorem. This is also called as Thales theorem. In your examination, sometimes they may ask you state and true BPT. It is in the short form BPT. It is expanded from basic proportionality theorem, otherwise state and true Thales theorem. If they give the question like this, you are expected to write the statement on your own and prove. Otherwise, if they give the statement, well and good, read the statement, try to understand and prove it. Here in this particular question, let us assume that they ask you state and true BPT. That means they have not given you the statement, they are asked you to write the statement and prove it. So what is BPT? BPT or Thales theorem is, if parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So this is the statement of the theorem. As we discussed in the previous video, the moment you read any mathematics question, three questions must have been raised in your mind. Do you remember what are the three questions? First one is what is given. Second one, what to be proved. Third one, in order to prove that what I require. So in those same lines, let us discuss here what is given. In the statement what is given, if a line drawn parallel to one side of a triangle, that means here I need to have a triangle, so this is a triangle. Let me name it. Triangle A B C. So as we discussed in the previous video, now we are moving the same lines. Along with the statement, I am trying to draw the figure. If a line drawn parallel to one side of a triangle, so a triangle I have, now we are going to draw a line which is parallel to one of these sides. So let me name this side. Once again, if a line drawn parallel to one side of a triangle, ABC is a triangle, DE is drawn parallel to BC, then what happens? To intersect the other two sides in distinct points. What do you mean that? This DE intersected AB at D and AC at E. D and E are two distinct points. The other two sides are divided in the same ratio. What are the other two sides? This line you drew parallel to BC. In the triangle, the left other two sides are AB and AC. So what you have to prove? You have to prove that these two sides are divided in the same ratio. What do you mean that? AD by DB is equal to AE by EC. So from this, what is given? We know what to be proved, we know that. Clear? In order to prove that what I require. So the third question, two questions you have answered. What is the third question? In order to prove that what you have to prove? AD by DB is equal to AE by EC. What I require. So by looking at this figure, have you got any idea straight away you can get that? I am unable to. So what I require? There is something related to triangles. We all know that area of a triangle is equal to half base into height. Clear? Height is nothing but it is the shortest distance. Nothing but perpendicular distance. So I need to draw perpendiculars. That is the construction part. And to score maximum marks, these are the hints you may have to follow. First you write given, next to prove, next if any construction is required, write it, then start the proof. So let us write what is given. Given that, what is given? ABC is a triangle. ABC is a triangle. And what else is given? DE is parallel to BC. DE is parallel to BC. This much is given to us. What you have to prove? To prove AD by DB is equal to AD by DB is equal to AE by EC. AE by EC. As we discussed earlier, straight away we are not getting any idea to prove. So, related to angle triangles, there is a area of the triangle formula half base into height. So, now I have to construct heights. So, what I will do? I will try to construct heights. Yeah. Let me name them. This is F, this is G. How I have constructed? This is a height that makes 90 degrees, and this height makes 90 degrees with F. So what I did the construction. Now let me draw the construction. So to prove our theorem, whatever you have constructed, that we are writing in the column construction. What we did? We draw DF perpendicular to AC, comma, EG perpendicular to AB. And also what we did? We joined BE and CD. Join BE, comma, CD. Clear? Let me go to next page. Now, whatever I require, I have constructed that. Now let me switch on to the proof. Proof. So, while proving, I have to keep what is my task in my mind. What I have to prove? I have to prove AD by DB is equal to AE by EC. So, as we discussed here, we are going to use the area of a triangle formula. So, what I will do? I will try to find the area of triangle ADE. Okay? So, let me say that area of triangle ADE. What is the formula of area of a triangle? Half base into height. Half base into height. That is equal to half. In ADE, what is the base? This is ADE. What is the base? Where is the height? Height is EG. So, EG is making 90 degrees with AD. So, AD must be base and EG must be height. So, half AD into EG. Clear? Now, let me go back again. Now, I have taken this. So, what I will do? I will try to take area of triangle AD. In this, I already got AD. So what you have to prove? AD by DB. That means you should have DB. So you should find another triangle where DB is included. So what I will do now? I will take the triangle BDE. That triangle I will take. Area of triangle BD is equal to area of triangle BDE. Yeah, look at here. BDE. What type of a triangle is it, BDE? It is obtuse angle triangle. In the obtuse angle triangle, where the height will be outside the triangle because it is obtuse angle. So for BDE, what is the height? Height will be EG and here the base will be BD. So area of triangle BD is equal to again the same formula, half into base into height, that is equal to half into BD into EG. BD into EG. Okay? Right. Now what I will do? I will try to find this ratio. Area of triangle ADE by area of triangle BDE is equal to, what is the value I got? Half into AD into EG by half into BD into EG. Now if you do the cancellation, half of gets cancelled, EG gets cancelled, then what is left over? The leftover is equal to AD by BD or DB. So let me name it as 1. If you closely observe this is what we have to prove, AD by DB. Either DB or BD both are same. Now already we got LHS part. Now it is enough if you prove RHS part. What is that? AE by EC. Now your thinking process must be like this. Where is AE? This one. Where is EC? This one. Similarly, same formula we are using, area of triangle formula. So I need AE. So AE must be one of the side, that is base. And there is a height related to AE. DF is the height. So what triangle I had to take? I had to take triangle ADE. So area of triangle AD is equal to area of triangle ADE is equal to, again same formula, half into base into height. Here half into your base must be your base is AE and your height is DF. So AE into DF. Similarly, area of triangle, let me come back to figure. What I require now? I got AE. Now I require EC. Where is EC? EC is this triangle. So what triangle I have to choose now? EC already I will get. So where is the height on EC? If I take this triangle CDE, this becomes a obtuse angle triangle. Height on this, so I have to take triangle CDE. So area of triangle CDE is equal to half into base into height, that is nothing but half into EC into again DF. So what I will do? I will take the ratio of this, area of triangle ADE by area of triangle CDE is equal to, area of triangle AD is equal to half into AE into DF, whereas area of triangle CD is equal to half into EC into DF. Again if I do the cancellation here, half gets cancelled, df gets cancelled. What is left over? Left over is equal to AE by EC. Now let me name it as equation 2. So let me come back. In equation 1 I got AD by DB or BD. In equation 2 I got AE by EC. What I have to prove? I have to prove AD by DB is equal to AE by EC. That means AD by DB is LHS is area of triangle AD by area of triangle BDE. AE by EC is LHS is area of triangle ADE. So both the sides LHS is same, and both the sides RHS is denominator is different, CDE. Look at here. Here the denominator is BDE. Here the denominator is CDE. Whereas here the numerator is ADE. Here the numerator is also ADE. Now what shall we do? Yeah. Area of triangle ADE by area of triangle BDE is equal to area of triangle ADE by area of triangle CDE. Now if you closely observe this, both these sides numerators are same and both these sides denominators are different. But still, if you look at the figure, BDE, CDE, these two triangles BDE, CDE, these two triangles lie in between the same parallel lines, that is BD and CE, and they have same base DE. So in your previous classes you have learned triangles which are having same base and lie between the same parallel lines have same area. In that, using that fact, is equal to this. What is the reason? Since triangle BDE comma triangle CDE lie in between same parallel lines and have same base. What is the base? DE. Okay, therefore these two are equal. But what is this equal to? If you come to equation 1, this is equal to AD by DB. So that is nothing but, that is AD by DB is equal to, what is this from the equation 2? AE by EC from equation 1 and 2. So this is what we have to prove, hence the proof. Dear students, hope you all have understood. Practice well. You can expect this question, I suppose. All the best.